Hello everyone, welcome to my new video. So this video I will solve the Pathria problem 1.11. Let's read the problem. 4 moles of nitrogen and 1 mole of oxygen at 1 atmospheric pressure and 300 Kelvin temperature that are mixed together to form air at the same pressure and temperature. Calculate the entropy of mixing per mole of the air formed. Okay, so this is not a very difficult question. This is the question from the Gibbs paradox, that portion. So please read this portion before solve the problem, then you get the feel. Yeah, let's go for the solution. So now think there is a two chamber, one is nitrogen chamber and one is oxygen chamber, and now we are mixing that gas and later the pressure and temperature that are given, N1, N2, I mean the number of molecules for nitrogen and oxygen that are also given here. So let's see the given data. So N1 is equal to 4 times of Avogadro number, because in the question tells that 4 moles of nitrogen gas and 1 mole of oxygen gas, and temperature are same and pressure is also same. So see the equation of 1.5.4 in Pathria. So there you will get this type of equation. This is entropy for gas mixing. So here all values are given, so just put the values. So I have put all the values, you can see. So after simplification you will obtain the result. Here I have used Na kV. Na is the Avogadro number, kV is the Boltzmann constant, and you all know their multiplication is the universal gas constant R. So after simplification you will get this type of result, nearly 2.502 R. So this is the entropy for gas mixing for 5 mole gas, because in the container there is 4 mole of nitrogen and 1 mole of oxygen, so total is 5 mole. And in the question we have to calculate the entropy of gas mixing per unit mole, so we have to divide it by the mole number. So we have divided it by 5 and the result is nearly 0.51. That's it. Thank you.